So in section 5.7, we're using the heats of formation to calculate standard enthalpy change. So in this example, we want to calculate the standard enthalpy change for the combustion of 1 mole of benzene, which combusts to CO2 and water. Okay, we now want to calculate the enthalpy change for 1 gram of benzene. Okay, so it's a two-part problem. We need to calculate for 1 mole of benzene, and we also want to calculate for 1 gram. First things first, balance chemical equation. So we have C6H6, which is a liquid, plus we know we need oxygen, which is a gas, and we are going to go to CO2, gas, and H2O, liquid. Okay, in this case, I'm going to give you the balanced chemical equation, which is 15 halves plus 6 CO2 plus 3 waters. Okay, if we want to calculate the standard enthalpy change using the following values found in the standard enthalpies of formation table, we know that delta H of reaction equals delta H of the products minus delta H of reactants. Okay, so now we can use this table to find all of our values. It's probably a little hard to find in the to observe in the video. However, you can use this. It's also found in your textbook. Okay, so let's start with the products. So we know that we have 6 CO2, so we need 6 times delta H CO2 plus 3 times delta H H2O minus 1 times delta H of C6H6 plus 15 halves of delta H of O2. Okay, now we're going to look in the table. So we have 6 times the value for CO2, which is carbon dioxide. Make sure the state matches. In this case, it's negative 393.5 kilojoules. We're going to add to that 3 times the heat of formation for liquid water, right? So down here, you can see kind of that it says water and water vapor. We want liquid water in this case, which is negative 285.8. Okay. Now we're going to subtract from that the heat of formation of benzene and oxygen. So benzene is here, it is liquid. It is 1 times positive 49, okay, plus 15 halves. The heat of formation of oxygen gas, if you were to look here, is not here, but it is 0 because this is in its native state. Okay, so now this part goes away, and so you can plug this into your calculator, and you get that delta H of reaction is equal to negative 3,267 kilojoules per mole. Okay. In the heat of formation, you would be provided this table, and you would be able to calculate this. One of the things you'll notice is that in these instances, I have summed up the sum of the products and the reactants separately. This makes it slightly easier to track your negative signs, particularly in the reactant side. Okay, this is good. I thought we were done. I forgot that the second part asked for the enthalpy change for 1 gram of benzene. Okay, if this is per mole of benzene, we need to figure out how many grams this is. So, if 1 gram of benzene, of C6H6, times the grams per mole, right? This will give us the molar value. It is 78.12 grams. Okay, in this case, we get 0.0128 moles of benzene. We can now multiply the moles of benzene by the kilojoules per mole to where we get negative 3267 kilojoules per mole times 0.0128 moles. When you do this, you get negative 41.8 kilojoules of standard enthalpy change, okay?